process data. So this is our main topic for today. And it will be a hands-on lecture. So I also want you to do some exercises when I finished presenting my slides. Even my slides are full of Python code. But at the second half of the course, you will code. I will give you some questions, and I will want you to do them. Okay, so what is data analysis and why we need explorative data analysis and visualization? So because we want to understand the hidden meaning in the data. So this is why we need visualization. So it is also a very important topic. I'm not a very good expert in visualization, but visualization helps us to see, to understand the hidden meaning in the data, and that's very important. And let's look at why we learn data visualizations. Because, for example, I'm not sure if you can see it. So there is a text here that describes data. But this text, even if you are a Turkish-speaking person, it is a little bit hard to understand. You can make a table like this one, or you can just draw the graphics. So when you draw it, you give the message in a very short amount of time. So this is why we need visualization. Okay, I want to continue. Okay, so we say that a picture is worth 1,000 words. So communication is much easier when it is nonverbal, when it is visual. Okay. So the purpose of explorative data analysis actually to understand our data, the tendency of the data, the hidden meaning in the data. It is not just about fancy visualizations, but visualizations help us. Okay. So I will skip. So for example, one of the very earliest work of data analysis, we can say that. So this is Jon Snow, this one, both of them Jon Snow at the same time. So this is a map, dot map in London, I suppose. So this is the cholera epidemic, and Jon Snow just made some dots on the map, and he understands that the cases are much higher in number around the pump, so he understands that it is something about the pump, and they shut down the pump, and it just helps to fight against the disease. So this is just one of the earliest examples that we use statistics and data visualization to fight against some problem. Okay, so the key question is, how can we transform data into information? This is the most important question. How we can transform data into information. Okay, so in this lecture we will do Python programming. I suppose you have some background in Python programming. Even some of you maybe have a much more experienced. Okay, we will see. And since I have an engineering background. Just a minute. Okay. Since I have an engineering background, so we follow this motto. So we don't talk too much. We just want to see the code. So this is Linus Torvalds, the father of the Linux. So this is the word from him. This is the quote from him. So this is how engineers communicate by showing their codes to each other. Okay. So I want to show you another example for the importance of data visualization. So this is some libraries in Python. I think you are familiar with all of them. Pandas, it is very good for data analysis and data science projects, and the two are for data visualization. So and we make an alias. We give short name for Pandas. We just say PD. For these one, PLT and SNS. And in the Seaborn library, we have a data set, flights data set. And you see we have 144 rows, year, month, and passengers. So when we look at this data, we don't understand much. Just look this data from another angle. So the same data, the same content, but shown differently. So here we just pivot to information. We just pivot to data. Here index, the rows are the months and columns are the years and values are the passengers. So this is how do it in Pandas. So this is the same data, nothing less, nothing more, same data. Again, but looking at this data, we don't see much. But if we make a visualization of this data, for example, in Seaborn library, there's a heat map, and you can give this data frame to it, and you can look at the data. Let's make it a little bit fancier. And you see this heat map, but now you say that the lines are in black, they have some thickness, so that's all. And now, by looking at the data, you start to understand something. You didn't do anything but visualization. So there is no mathematical things, there is no machine learning, there is no statistic. We are just looking to the data from another angle. And we can understand, we can conclude some points. So we understand that these are the months, and the red color means that much more passengers. We have much more passengers, and we understand that at July and August in summertime, the number of passengers using flights are much more higher, and we understand that by year the number of passengers grows annually. So these are the conclusions that we can make just by looking at the data. So this is an important thing. This data visualization must be in our toolbox. Okay, so this is just the beginning. This is just the beginning of our course. Okay. For the moment, I will skip the last 3 slides and go to another slide now. Sorry. Okay. Now we will start to see much more code now. These are related to the phases of a data science project. So first of all, for example, maybe you are in a company and company has a business and they want to analyze something. So related to their problem, data requirements changes. So to solve the problem, this business problem, we need to collect data. Then we need to process this data, do cleaning. So this course, now the lecture will be about this data process and data cleaning. And at the end, we will do some exploratory data analysis. So this is to understand the message contained in the data. Then everything is finished. Now data, the work related to data is finished. Now we can model and use machine learning algorithms in the data. So we can transform into a product and we can communicate it to customers likewise. Okay. Okay, so I will skip this one. Now we will talk about this data cleaning and preparation part. In a data science project, as you know, and as you heard much, so this is the this is the tedious work, maybe an ugly work, and this is the most of the work is gone to the most of the effort is gone to this data collection and data processing and data cleaning part. And even they say that 80% of the work or effort in a data science project is related to data collection, data preprocessing, and data cleaning. And since algorithms are pre-built in the libraries, for example, if you want to use a machine learning algorithm, you will go to scikit-learn library. If you want to use a deep learning algorithm, you will go for PyTorch or Keras or TensorFlow. So algorithms are already in the libraries, but the data comes in a raw format. And we need to process it, because if there are, so what might be the cases? So there might be duplicates in the data. There might be missing values. There might be outliers. Maybe format is not appropriate. So there are a lot of work to do. And this lecture will be about this data cleaning and preparation part, which is an ugly part, but we need to do that. Okay, so what we will do, we will handle missing and incorrect or duplicate data. We will see how to do that. And we will see how to handle outliers. And we will talk about some data transformation and maybe about class imbalance problem. Okay. So why we need to transform our raw data into a clean and structured format? Because there is another motto in data science or machine learning. We say that garbage in, garbage out. If your data is full of outliers, then your models will not work properly. So you need to prepare. This is a must to get optimal performance from the data. Okay, there are a lot of things here. Let's go by one. Okay, so how to handle missing values? Now, what I will talk about is related to Pandas library, and we will also see some machine learning, scikit-learn from scikit-learn library. Okay, so for example, you have a missing value in your data set. What can you do? You can drop these missing values, or you just ignore the missing values, or maybe you can fill missing values, but with average of the data. So these are the primitive ways to handle missing values. Let's look at them. For example, now the code here is just for generating a synthetic data. So now you are seeing also how to generate synthetic data. So this is also an important step to make controlled experiments. So again, we have NumPy and Pandas libraries. NumPy for linear algebra, Pandas for data science. We have when we make a stochastic application, or we make something in a stochastic way, we need to set a seed, because if we set the seed, since this is a pseudo-random process, everyone can get the same results. So if you apply these codes, Akın Hocam, did you give the all the materials to our students?
Yes, I sent them. You all have the zip file in your email, so yes, you can download.
Okay, if you want, you can also try. For example, the first one is here. You have the code for the first slides, and now we start with the missing values. So you see, you can run them. This is Jupyter Notebook. I hope you have necessary materials and the libraries, and you can run it. If you have any questions, please interrupt. Do not hesitate and interrupt to ask questions. So here, I am generating a synthetic data. Here we have 100 samples and 5 features. So this is not true. This is 10 rows and 5 features. Now I have a list for column names. Now from this NumPy random data and column names, list of names, I create Pandas data frame. And this is the data frame I created. Not exactly, because there is also another instruction here. We inject deliberately. This is a controlled experiment, and we are creating our own data. And we inject here missing values. So this is not a number from NumPy library. This is NumPy, not a number. So here you see from row 3 to row 5, but row 5 is not included. So this is inclusive, this is exclusive, and this is the column 1. So this is column 0, column 1, and you see from 3 to 5, 5 is not included. So here we introduce missing values. So we create our data with missing values. So again, I repeat, this is a controlled experiment. Okay, I don't know if I cannot see the chat if there is a question.
Uh,
Okay, so
I am monitoring. If there is a question, I will just ask it to you.
okay. Okay, so this is our data now. So now we have a simple data, synthetic data, in which we have some missing values. Now we will deal with these missing values. Okay, so first thing that comes to mind is just to ignore the missing values. You see, this is data frame drop NA, and you don't see anymore this row 3, row 4. You see 0, 1, 2, row 3 and 4 is gone. And again, for 6 and 7, the same thing. You don't see, you just ignore. You drop the missing values, but maybe it is not a good idea, because maybe this is a very valuable data in feature 1, and you just miss it because of this feature 2. So this is not the best way to deal with missing data, because the other ones, maybe they are very valuable and you want to keep, maybe you pay a lot of data to get this information here, this data here. So you don't want to miss because of this missing feature 2. So we need another method for that. So second thing that we can do is the fill these missing values with average values. So DF mean, for example, here we fill NA with this mean values. But this time, okay, this is better than the first one. But this time you see here we keep the number of rows. For 3 and 4, you see they are given the same value. Actually, this is the average of feature 2 is given. So average of feature 2 is given to this missing values, and average of feature 4 is given to these missing values. Okay, you see they are the same. And this is better than the first one, but here maybe row 3 and row 4 is completely different things, but you give them same value in feature 2. Again, this is better than nothing, but there is a complication also. So we can do something better than this, and this is something that is known by the community. Even in the data science community, they do not know how to fill. What is the better way to fill this value? Okay, don't look at the slides coming. Just answer. Do you know how to fill this data better than mean value? Do you have any idea among the participants?
Maybe with regression models.
Yes, it is in the slides. Yes. Did you see it, or did you knew it before?
I knew it before.
Okay, very nice. Okay.
I think there is a package named as Amelia in R. Maybe you know, the first American follow fighter.
Okay, very nice. Okay, congratulations. Okay, normally even computer engineers or data science, the people who calls them data scientists do not know a better way than this. So we will see today, and our friend knows it already. Okay, so you can fill with median also. Same thing, doesn't change. Okay, by the way, what is mean, median, and mode? I think you all know what are they. So these are the central tendencies in the data. Okay, so you see, for example, if you have a data like this one, 1, 2, 2, 3, 3, 4, 4, 5, 5, 5 repeats 5 times. So the mode is here. The most frequent one is 5. So because of that, mode is 5. Okay, take it like that. Okay, and mean and median is median. What is median? So this is already sorted, but if it is not sorted, what we do, we sort it from lowest to highest, and we just go to the middle point. What is the data in the middle one? So it is called median. So it is 50% of the data. When it's sorted, we see median. So we see it. I think this one is the median, and mean, we know it. We just sum and divide by the number of points. Okay, I will go. Okay, now we see the better way. for dealing with missing values. So again, we create a synthetic data. So this is our list of lists. What you see is a list of lists. So this is list inside another list data. Okay, we give it to the Pandas data frame, and we specify the column names here. So this is our DF. If we see DF data frame, you see we have missing values here. So how to handle these missing values? So this is a synthetic data. This is me who generated it, so I know what it is. So this is C is A plus B. So 3 plus 4 makes 7, as you said. So this must be 11, and this must be 3. We know it, but we want our algorithm to find it also. So how do we do it? So this is not a machine learning course, but it is very easy to use machine learning libraries. So from scikit-learn linear model, we import linear regression. And now we are ready to use linear regression in Python. Okay, so this is our data frame. Here we drop NA. So df drop NA. So we drop the first row, we drop the second row, and we have just 3 rows in df drop NA. Okay, in this one. So from here, our target is the column C, and our input is all the columns, but not C. What does this mean? So our predictors is A and B. So this is our input. Input is the column A and B, and one that we want to predict is the column C. But don't forget, this is we don't have the not a number. We just ignore not a number, then we do this X and Y here. Then we make the linear regression, and we fit from this input to this output. So it learns the mapping from input to output, from predictor to target. So this regression learns it. Now we can make prediction, and we see that it can predict 7, 15, 19. So it learns the mapping from X to Y. Okay, this is good. Now we will use it to predict the missing values here. So I will go to next slides. Okay, so our input is all the columns, but not C. We drop C here. So this is predictors are A and B. Okay, from the same model that we trained regression, we want it to predict from this input. So these are its predictions. So these are the outputs, and you see this is 3, 7, 11, 15, and 19. So you can predict here with linear regression, you can predict the missing values. So now comes the question. So we did it for regression. Very nice. First of all, can we use something different than linear regression? My first question. Do you suggest any other model than linear regression?
So Yasar says KNN. Alina
Yes.
says KNN as well.
Okay, very nice. Now my second question. So here, C, the column C might be, for example, in Titanic data, you know, there is a sex column, male or female. So it could be male or female, like that. So the categorical column. So in this case, what algorithm we can use? Can we use linear regression, or can we use any other algorithm than linear regression? So my second question.
Murat Cerit says log regression, but I don't know if it's for this or the previous question. So we have a log regression answer.
Yes, log regression. Why log regression?
Şimdiki soru it was the current question.
Last question. Okay, thank you.
Because we are interested in categorical variable, so that's why we need to predict a categorical variable, which is kind of logarithmic.
Exactly. When it is categorical values here, and we want to predict missing values in the categorical column, we cannot do linear regression because linear regression is for regression. It predicts something, a real value. So it is like the price of a house, like that. But when we want to predict a category, it means we are trying to solve a classification problem. When it is a classification problem, we have different kinds of algorithms, and the easiest one is the logistic regression, even if the name is misused, regression, but logistic regression is for classification. Okay, so this is the machine learning part, but I think you are already know it, or you will learn it. Okay, duplicates are also it can cause, when there are duplicates, it can harm the statistics such as mean, median, and mode. So we want to deal with duplicates also, and it is also easy. You can just in Pandas, since we are using Pandas, there is a function or method called drop duplicates. Then you can easily drop duplicates. So for example, this is our data frame, and we have 1, 2, 3 here, 1, 2, 3 is exactly the same content. So if we run this df point drop duplicates, what we have is this one. The first is kept, and all the rest, if there is more than one duplicate, they are all will be gone. Okay. You can also make drop duplicates or drop NA in a subset of columns, not all the data, but in a subset of the columns. So this is a parameter that you can use. Okay. Okay, now I will talk about outliers. So outliers is really something we need to deal with. So as I told you before, garbage in, garbage out. So this is garbage comes from this outliers generally. So we need to get rid of the outliers. And I will show you the basic statistical methods for removing outliers, but there are much more sophisticated algorithms for outlier detection. It is also called anomaly detection, by the way. And it is just the opposite side of the pattern recognition. In pattern recognition, we want to understand patterns in the data. In anomaly detection, we want to understand what doesn't fit to the patterns. So this is just the complementary things. And it's very important. Anomaly detection is very important. But what we see is outlier detection. And it is the simplest form of anomaly detection. And it is just what we will see is about just column. So maybe in one column, there is no outlier, but the combination of two columns make an outlier. But we will not see how to deal with that. So for example, in one feature in your data set might be age, and one feature in your data set might be the number of childs the person has. So for example, one can be 18 years old. This is not a problematic. This is not an outlier. And people can have 1 child, 0 child, or 3 child. So this is not an outlier. But the combination of two, for example, an 18 years old with, for example, 4 child. So combination of two, you do not expect it to be true. So where outlier might be not just among one feature, but the combination of the features. So problem becomes a little bit more problematic when we deal with the correlation or the relationship between the features. But what we will see is just in one column. We do not include the relationship between the features. Okay, so what we will see is very simple method called z-score. But we have one assumption here. We think that the data follows normal distribution. Why we think that? Okay, I will just look at here. Okay. Okay. So people think that most of the distribution that we see in real life can be explained with normal distribution, this bell curve. So this is the height of women and men. So this is not, this is a sample from United States. I don't know if it is true. I just find it before the presentation. So I didn't really verify it. But most of the measurements, most of the data follow normal distribution, and this normal distribution has some properties, as you might know. So you have the mean and you have standard deviation. If you go from mean one standard deviation away from both sides, data almost 70% of the data is one standard deviation away from the mean. Almost 95% of the data is two standard deviation away from the mean. And when you go away again, the data becomes less likely to be happened. So here you say almost 100% of the data is in between three standard deviation away from the mean. So almost all the data is in three standard deviation away from the mean, if the data follows this normal distribution. So we can say that it depends on your data, but if some data point is more than three standard deviation away from the mean, then we can call it an outlier. So this is the main idea for outlier detection with z-score. So how do we calculate z-score? So this is the data point. You just subtract the mean of the data and you divide by the standard deviation. So it gives the how much standard deviation away this data point from the mean. So if it is greater than 3, we think that it is an outlier. So this is the main idea. Again, I just make data here, synthetic data. Okay. And I inject an outlier to the last column, as you see. These are just numbers between -1 and 1, or maybe 2. Okay. So these are very small numbers, but I inject here 300, 200 likewise. Okay, so I want my algorithm to detect these outliers. Okay, so how do we do it? From this data frame, we subtract the mean and we divide by the standard deviation. So this is called z-score. Okay, and when we do it, you can see that. So these are the z-scores, and for the outliers, we have something greater than 3. Okay, so this is how we detect outliers with z-score. And here in this data, this is called z. In this data, who are the ones that are smaller than 3 here? Our threshold is 3. So these are all smaller than 3, but at the last column, this is false. So it is not smaller than 3. So it is not normal. It's not normal, not normal, not normal like us. Okay. And we say that all this is z smaller than threshold, all of them. So we make an and true and true and true and true and so it gives true, but true and false gives false. So because of that, so this gives us the index in the axis 1. So by the way, this is axis 0, the rows, and axis 1 is columns. Here we just here you see we do not have the 11th row here because it doesn't hold this condition. What is the condition? All the features must be smaller than the threshold. So z-score must be smaller than 3. So we do not. So 11th row doesn't have that. So this one doesn't have that condition. So we do not see it here. So this is the code for z-score. Okay, do you have any question for z-score? It is a little bit complicated, but the code that I show you is a little bit complicated, but you can use it. You can find, we as programmers, we do not really know everything. We just Google it now. But these days we start to chat with ChatGPT and get the necessary code and use it. So we do not know all the things. I will also forget this code and I cannot write it again when I finish this presentation. For example, tomorrow it is a little hard for me to write this code, but I will find somewhere and I will understand it and I will use it. So this is the same for all programs, I think. Okay. So this is a more robust method called modified z-score for outlier detection. So this is a more robust method for outlier detection. It's called modified z-score. Instead of using mean, we use median. Okay, so this is a little bit advanced. So it is not very necessary, but if you are really into do outlier detection, you can use it. So this is a little more robust way to do outlier detection. It doesn't change much. I will by code. So this is the synthetic code here. Just a minute. For example, here z-score doesn't work well because our data set, the number of data is a little bit lower now. Previously, we have 12 data points. And at that time, z-score worked well. But when we have a smaller number of data with this anomaly, z-score doesn't work. So you see z-score doesn't work all the time. So here it cannot find the anomaly, the outlier. The code is the same. We subtract the means, divide by the standard deviation. But the median, the modified z-score finds it. Okay, so this is the, first we subtract the median, and from this data, we find this variable mat. This is the median of median. And then we subtract median and divide by median of median. And it helps us to find, but it is a little bit advanced. So okay, it's not much necessary. Okay, another way to find outliers called interquartile range, and it is the same thing as z-score exactly. So when you have a data and you make them sorted, so the point in the middle, exactly in the middle one, called median. So this is the 50th percentile. This one, quartile one, is the 25th percentile, and this is 75th percentile. It is called quartile 3. So this is called interquartile range, and this is the distance that we are interested, this interquartile range. So we find the first quartile, then third quartile. We calculate the interquartile range. We define the lower and upper limit with these calculations. And this exactly corresponds to the very near to 3 sigma, but not exactly. It is written here, 2.7 sigma. So it is like a z-score, but we are not using 3 sigma, but this one here. So this is the same thing, actually, and you can use it. I will not. So this is, again, with Pandas, it is easy. You can find the quartile 1, Q3 range between these quartiles, lower and upper limit. Then you make these conditions. Outliers are the ones that are smaller than or less than the lower limit and greater than the upper limit. And I said and, but this is or. So these are the conditions, and you can find the outliers. So this is how you handle outliers. Okay. Okay. I will talk about some 1 or 2 important things, and then I will finish in 4 minutes. And after that, we will make a break, if it is okay. Then I will give you questions, and I will want you to do that questions. I will talk about 5 minutes, then we will make a break. Okay. Okay. So, you know, when we do data science, feature scaling is also important. For example, we have features. For example, in your data, there is an age column. Age column is between 0 and 100. And there is a salary column. It is in between, you say, thousands or thousands. So this is they are very different in scales. One feature is between 1 and 0. The other one is between maybe 0 and 100,000. So the scales are different. So we need to make them in the same range, in the same scale. So what you can do is standard scaler. Again, you can use scikit-learn like this one, and it does it automatically for you. But sorry. Okay. I don't know if I have the. Okay. Normally, you can also do like we did it in the z-score. So this is what we do here is this, we just subtract the mean and divide by the standard deviation. So you can do it on your own, or you can use this library. Okay. So for example, in data, you can have incorrect data. You can easily spot it and change it. For example, in the age column, in your data, maybe in the age column, there are negative values. No one can have negative age. So you need to spot it. For example, if it is smaller than 0, you make it 0 or you drop it. Okay, like this one. You can handle incorrect data. Okay, I say that when we do outlier detection, we had an assumption that the data follows a normal distribution. What if it doesn't follow the normal distribution? You can do some mathematical tricks. For example, log transformation, square root transformation like this, to make it look like a bell curve. Then you go with the outlier detection methods that we have seen. For example, this doesn't look like really look like a bell curve. The shape doesn't fit. So you can make a transformation with logarithm transformation. It doesn't look like a bell curve, but it is better than the original one. So you can do these kinds of transformation in the data. Okay. So this is data normalization. So min-max normalization. Again, you can take it from scikit-learn preprocessing library, or you can do it on your own. From the data, you subtract the mean and you divide by the range between max and min. So this is min-max normalization. This is z-score or standard scaler. You subtract the mean and divide by standard deviation. For this one, you have the library. You can see it. But for min-max scaler, all things are same. Here you write min-max scaler. You write min-max scaler, and you do it. You do this normalization. Okay.
We have a question, Hocam. Murat asks, what was used exactly to scale the variables? Is that standard deviation?
It depends. It depends. Both works. Min-max scaler and standard scaler works. You can select one of them. There is no really big difference.
Thank you, Hocam.
Okay. Okay, and I talked about a little bit about anomaly detection, and for example, fraud detection is one example of anomaly detection. So fraudulent activities are very rare when we compare it to the normal activities. So here, for example, this is fraudulent activities in a bank, in a financial institution. Fraudulent activities are very rare. but the normal actives are very high. So there is an imbalance in the data. So in this case, this is called class imbalance problem. So what you can do, you select random rows from here and you ignore the rest and you make them equal in size, like this one. This is called undersampling, or you can make oversampling. You can copy this data, exact copy. This is not a good way. For example, in image processing, when you have the images, you just change the angle or you change the color. For example, cat and dog images, you have cat and dog images, but you have very small amount of cat images. What you do, you take that image of the cat and you just rotate it a little bit and change the color, and you synthetically create other cat images by yourself. So this is oversampling. Okay, and this is again, there are a lot of advanced methods to deal with class imbalance. For example, one is SMOD. You just create data points. For example, oranges are small in number in compared to blue ones. So you just, in between oranges, you create new data points, new synthetic data points. But this is another big topic, so we will not talk about it very much for the moment. Okay. Just a minute. I will share my screen again. I want to talk about the exercise part and give it to you before the break, and during the break and after the break, you can deal with it. So these simple questions, I want you to try on your own and discuss what you can do, what you couldn't do. Okay, now I will share again.
There's another question from Ayşe Duman. When can we use log transformation in our data set?
Okay, so actually this is another advanced topic, and I also have a little knowledge about it. But what log transformation does it just, for example, you have a growing data, and you want to deal with this growing the big data. You want to make it small. So log transformation is to make big data small. Big data becomes small. Small data doesn't change, but the big data becomes gets very smaller. So data becomes more balanced. But I'm not really an expert, so I couldn't explain it very well. But you can look for it. For example, what we have seen is to make it more look like a bell curve. Okay. I suppose there's another question. Okay. I can't see you. How can I see you?
What, hocam?
Actually, I wanted to make a comment, if I have chance to do it,
Yes,
about
please.
log transformation. If the distribution of the data is relatively not normal, and the scales are so different from each other, that we can use log transformation to make the data a little bit scalable, a little bit normalized. So that is the main idea behind the log transformation.
Thank you, Murat Hocam.
Thank you.
Okay. Is there any other question?
Nothing on the chat.
Okay. Then, so this is your exercise. You can see it in the zip file that we have sent you. So these are the questions. So you just read the data. For example, this is a column name that we don't want to have. So again, the column values are unnecessary. So you remove the unnecessary column. You do it on your own. And you look to the standard deviation of each feature and remove columns with standard deviation less than this threshold. Again, if you look at I think feature 2 doesn't change. It is just 0. So it doesn't give any information. So you need to remove from it. And I think there are some missing values. Drop them. And then check for correlated features. So what is the correlation between feature 0 and feature 1 and feature 3 likewise, and show it with the heat map that we see for the passengers flights. Okay, and just show it. So this is a very simple data cleaning process. And then we have another question. Here, again, this is the synthetic data that we have seen in the slides. Like it's very similar to that, but this time, not only we will predict this C values here, but we also need to predict this one. Okay, so this is a little bit complicated than the one that we have seen previously. So these are the questions that I want you to try. Okay.
So where was this? How did you open these questions? So it's in the file that you sent us. What is the name of the file in case people...
Okay, I will look for it now. Just a minute. So this is in the exercise, you have this one. SICSS exercise.
Okay.
Can you spot?
Yes, yes. There's
Okay.
both a data CSV there and SICSS exercise IP YNB. So how many minutes do you think would be sufficient for this?
I think we can make a 15-minute break, and after the 15-minute break, we can take the questions if there are any.
Okay.
After the break, we can wait for 15 minutes more, and then we show the solution, and we finish the lecture.
Okay. So let's take a break for 15 minutes. Let's be here at 8:15. See you soon.
Okay. Thank you.
Time.
Okay. Hello again. Okay. So this is the exercise that I prepared for you. So you have this data. In the first question, the task is to remove unnecessary column. This is this column. Then remove the column whose standard deviation is less than this threshold, and it corresponds to that one, but you will find it automatically. You don't know which one. Okay. And then you will have 3 columns. In that columns, you will have some missing values. Just drop them. Okay. And after that, look for, check for correlation. I didn't show it to you, but just use Google and to see how to detect correlation in Pandas data frame. You can easily find it. And then plot it with the heat map that we have seen in the first presentation, and just look at the data. So that's all. So this is the first one. And the second one is about handling missing values with a simple machine learning algorithm that's called linear regression. That is the thing that we have seen in the second presentation. But this time we have 2 columns with missing values. So it is a little bit one tick more complicated than the one that we use. So find a way to get rid of these 2 missing values by using linear regression. So this is the second question. A little bit tedious and harder, but I'm sure you can do it.
Okay, so I know in this group there are those very proficient in Python. So shall we say 15 minutes for this?
Yes, yes.
So like at 8:35, we can perhaps have some of those people who have extensive Python experience who might find this exercise easy to explain how they solve. So instead of maybe Uzay Hocam explaining the solution, we can get Python experts in our own cohort to give us a presentation on how they did it. It would be so good, so that others can know who they're going to ask questions to later on in when the project starts. So let's say, sorry, I accidentally wrote to Leon. I have to write this to everyone. It's 8:35. This is our deadline. So we are here in case you need to ask any questions. So yeah, just 15 minutes on your own time here. Okay, it is 35 past. Let's see the lineup. Who did what? So first of all, who completed the exercise successfully? Like do a reaction like this. A 1, 2. I know there are more experts, more Python experts here. Maybe so it was too short, maybe the time. Maybe they needed a little bit more time, because I know there are people who did projects on Python. But as I said, Uzay Hocam, even if people do advanced stuff on Python, this, fundamental exploratory data analysis is something that is usually very weak with people, even with engineers. So that is why I value this session quite a lot. And I think this is, to me, the most important foundation of any programming language, be it R or Python. So who wants to present their solutions? It's an ultimate icebreaker. You would be famous in our community. People will approach you and you will be very much liked very immediately. You will get a ton of emails. Teach me Python, teach me Python. So who wants to go first to present their solution? No pressure. I mean, even if you did wrong, it's okay. We're still in the boot camp. We are going to throw you out when the actual institute begins. So it's still early. Anyone? Is it somebody who said who did thumbs up? Anyone?
I think much more people that can do the first question. First question is a little bit easier. So okay, don't be shy. Just pick it up.
Be shy. It's okay.
Okay, can I go
Yes,
solution?
yes. So
Hi,
can you
Uzay
share
Hocam.
screen?
Nice.
Selam Barış.
Okay. Let's go.
Hang on a minute, dear profs.
You should be able to share screen. I gave everyone permission.
Okay, I will do it. Just hang on a minute. Is everyone show my screen?
Yes.
Okay. Okay. First, removing unnecessary column 2, unnamed 0. I make a class, name the data, the equal data dot drop, and open the parentheses, write the name, which columns I will drop it, and comma, and I will write the axis equal 1. Then feature unnamed 0, 0. May I continue?
Yes.
Okay.
Barış, is it possible to make it a little bit bigger for you?
Okay.
From the 3 points, yes.
Okay. The second question is remove the columns with standard deviation less than 0.01. First, I will make a class standard deviation values equal to data and standard deviation. Then I will write the select columns equal standard deviation values square brackets standard values, which is the greater equal than the 0.01, and make an index, new index, and I will be make a new data class. After when I printed new data, its standard deviations look like this.
Okay. Very nice. Barış, can you show us std values, std dash values? Just the value of the first line, yes.
Can you repeat again?
I want to see what outcomes the data point std. So the variable that you call std values. No.
STD.
Oh, sorry.
Okay, very nice. It gives us the standard deviation for each feature, and you select which the appropriate one. Okay, very nice.
And third question is removing missing values. Just data is equal data.drop NA, and our first set is 1000 rows and 3 columns, and now we have just 2 missing values. And check the correlate features, remove the columns with correlation greater than 0.95. I'm not sure about that solution. Maybe you will help me if this if I will be going to for solution. But first, I make the class is correlation matrix name and equal that's correlation function and ABS function called the ABS function to make it another class to drop square brackets and column for column in correlation matrix columns if any correlation matrix column greater than the 0.95. And data class is to drop to before the class to open the square columns equal to drop and printing the data dot head, and it shows the feature 2, but I show this, the feature 3 is have some greater than the 0.95, but am I mistaken or not? I'm not sure. I'm just asking you.
Okay, it would be easier if we make the heat map before, then we see which correlation values, and then we detect which feature to drop. I can show my code if you want. So
it would be great.
Okay, when you finish, I can show it. Okay.
Okay. I didn't make it.
Okay.
Visualize correlation with heat map and pair plot, but last one is, if I'm not going to wrong understand expansions, remaining that a 2-dimensional space, but we have 3-dimensional space, and I called the scikit-learn library from the principal component analysis. And is it true solution or not?
No, it's a little bit advanced. Normally, actually,
yeah, maybe I will be just show, because feature 2, when we look at data frame, it's feature 2 whole.
Yes.
Yeah, whole rows is 0, and just we call the first solution is maybe data equal data drop and open parentheses unnamed feature 2 and axis 1.
Yes,
Then
exactly.
the solution is gonna be, yeah, that's all, dear prof. Thank you.
Thank you. Very nice. You have done almost all of it. Very nice. Okay.
Nice.
Uh, I can rapidly show solution for the first one, then some other participant can show the result for the second
Yes,
question.
please.
Okay. So, as Barish did it, so we just draw it. Axis 1, specifying axis 1 is important because it says that we will drop a column, and the column name, it is given in a list. So this column will be dropped. And when we say in place true, we don't need to make df equals df drop. It will done in place. So we will get rid of the column. Okay, we can there is for data frame, there is a describe method, and we can see statistics of features. When we make dot t, it is just transposed. So we can see that for feature 2, we have this much count, but the mean standard deviation, all of them 0. So it doesn't change. We know it from the data. So there is no variation. When there is no variation, there is no information in the data. So variation is very important. It's actually one definition of the variation is information. So there is feature 2 doesn't give us any information. It doesn't vary. So we need to get rid of these kinds of features. So like we done before, we drop it in place. This is like that. And this is where we have missing values. And so here, so this is not a missing value. This is not a missing value when it is false. And when we sum it in the axis 0, it means that we sum column-wise. Yeah. And when we sum false plus false plus false, it makes 0. Okay. False is 0, true is 1 when it is sum. Okay, so when we sum it, excuse me, axis 0 is the row-wise. So we sum on the rows. So we sum over here. So in feature 0, we have 4 trues that are nulls, that are missing values. In feature 1, we have 2. In feature 3, we have 2. So this we can see how many missing values we have. So if we want to see in percentage, so we can divide by the number of rows we have. Okay, we just drop them. Okay, and then for the correlation, we have data frame. We call correlation methods. It gives us a matrix, and in which we have the correlation between features. You see, feature 0 is very correlated with feature 3. It is greater than something acceptable. For us, it is 0.95. So we will, we specify it. We understand that feature 0 and feature 3 is very related. So we just get rid of one of them. We after visualization, we select feature 3 and we get rid of it. So first we see the correlation matrix visually, and then we decide to remove feature 3. So that's it. And pair plot is again advanced visualization tool. We can see dependency between features, and this is our data. Okay, so so that's all for the first question.
So what do we do now? Do we go to the next question, or?
If some volunteer want to explain second question, their solution, it would be great. Otherwise, I can show.
Okay, has anybody done the second question?
Hocam,
Yes, please.
I know how to, I guess, but I couldn't, like conduct and practice, like the answer. But I thought I just want to ask Uzay Hoca, are we going to do it like first 4 rows, 2 NAs, and then the last one? Or are we going to, like tell the formulation and then are we going to use it with a formula? I was wondering about that.
The key is to have 2 regression, not just 1. We need to have 2 linear regression. One linear regression to predict C from A and B, another linear regression to predict A from B and C. So that's it. We need 2 linear regressions.
Yeah, okay, thank you. I thought so.
Okay. Okay. Akın Hocam, do we have time or?
It's up to you, Hocam. I mean, we stop at 2nd hour because we don't want to abuse the time of our instructors, but it's entirely up to you.
Okay. If any volunteer wants to show its solution, we can look at it, or I will continue and finish in 5 minutes. I give the main idea.
I
Yes.
think even if you haven't completed the task, but progressed to a certain point, I would say present it and then get feedback. That's the best way to learn.
Exactly.
Don't go for perfection. This is boot camp. I'm going to go for perfection in the final presentation. So this is the part where it's okay to have anything. I'll just say, if you have started, anyone could go through, what they have done, at least.
Be courageous.
Yeah, they're in the
Hocam,
Bible.
okay, I'm doing.
Okay,
Okay, I'm
please.
sharing my screen.
Please.
Yeah, I did, like, I tried to drop the 5th row, but this should be, I guess, no, okay, it's fine, I guess. I tried to drop it and then move on, but yeah, it didn't work. At some point, it just keep on having, I guess there is something wrong with the variables because I copy and pasted it from your code. So yeah, just open to feedbacks.
Okay.
How dare you call Uzay Hoca's variables wrong?
Hocam, I was almost going to ChatGPT, so don't judge me.
Okay.
Okay. Okay. Then I can show my code then.
Yeah.
If you want. It's similar. It is very similar to that. Okay. Then I will show it. Okay. It is I think this question is a little bit hard. So it is very normal if you have problem with it. Even data scientists, they don't know how to do this kind of handling missing value. So don't worry, you know something much more than standard data scientists now. Okay, so this is our data. This is in data frame. We have 3 missing values, but in 2 different columns. So, for example, when we drop an A, we can also select from which column. For example, here, we only drop missing values from column C. So we keep, for example, this missing value A here. It is not that important, but it is good to know. So if you drop an A from subset A, again, C missing values in C kept, but we drop the missing values from A. Okay. So this is when we drop an A. So this is df drop an A. So this is the data that we have. There is no missing values. Now we will we make a prediction from AB to C. So this is our first regression. Then we will make a regression to A. This is regression to C. So our training, our X data is the columns A and B here. Columns A and B. So when we drop C, all we get is columns A and B. And when we select column C, this is column C. So, so from A and B, we will predict C here. This is our linear regression. We fit from X input to output. So this is AB to C. So this now the mapping from AB to C. Okay. Now we just drop an A from A. Okay. So here, this is this one. So this is df drop an A subset A. We just get rid of the missing value from A. Now we are using this AB to predict C. In the training data, we just use this one. So this is our training data. From A and B, we predicted C. Now we will use this data. From A and B, we will predict C. And these missing values will show themselves. And when we do, so this is test X is the, again, here. And this time we give this test data. Test data is this one. And now it will predict C. Here we see 5, 11, 17 likewise. So 5, 11, 17. So we know now this should be 5 and this should be 17. And since this is a synthetic data, this is a controlled experiment, we know C is A plus 2B. So here, this is A1 plus 2 times 2, 5. As you see, it predicted 5. You can see this is it. So this is the first prediction. Now we will predict A. Now I tell you, I realize that it's really a hard thing to do. Okay, is there any question?
Yes, hocam. The other predicted value 17 does not meet the condition.
Really? Let's look at it.
I was going to ask the reason why.
Oh, you are right. You are right. Okay, I don't know why. Okay, let's do it again. Let's run it again. Kernel, restart and run off.
I mean, I did exactly the same, and I also got 17.
Okay, now, so the data, okay, so it make a little mistake. So algorithms can make mistakes too. So it's a little mistake. So, we want to minimize this error, but we need to minimize that error, we need more data. I suppose we have very little data. So this much 3 data point is not enough to make correct prediction. That I suppose this is the reason, but it's not bad. It's not bad. It's not a very different thing that from what we expect. Okay, but thank you. I didn't realize it. Okay. So prediction A, similar thing. This time from df drop an A, we drop columns. We drop column A. So what remains is B and C. B and C, and we select column A here. From B and C, we will predict train Y. So we need another linear regression model, and it will have different parameters. So we train it here, another regression. Now it is from B and C, it will predict A. Okay, and now when it learns the parameters, now it can be used to to make prediction on unseen data. Here, again, this is it true? Drop an A subset C. What does it gives? Subset C. Okay. df drop an A subset C. This is it. Now we have here this missing data. From B and C, we will predict A. Okay. Evet. dfc. This is here. It's not there. This is here. From that, we drop column A. We have B and C, and we will predict column A here. Okay. Okay. From test X, we make with this learned model, trained model, we make test. We make prediction on test data, and here, let's see it. Sorry. So here it predicts the first three one, it learns them, and for the last one, it predicts two. And our equation is 2 plus 2 times 3, it makes 8. Okay, so it learns it good enough. Okay, so this is the solution. Okay, it is a little bit hard one. It is not just data science, data analysis, it is a little bit machine learning. So this is why a little bit harder than we expect. Okay. Evet.
Okay,
So-
any other questions or?
I can send the solution if you want.
Okay, did you share screen or? So you can send the solution either through chat or via email. I can forward
Okay,
it
I
to
can.
them.
Now I am sending it from the chat.
Okay, so that everyone can copy.
Yes.
So there are messages from chat to me that are requesting certain Python, help refreshers as well. Some of them are converging. I need to know the full list of people who need, setting up an IDE, getting a tutorial on PyCharm or Colab or something like that. So for me to be able to get a full list, just email me. Email me with all of your Python needs, because I can teach R myself anything you need. On Python, I use it rarely, so I'm going to ask either Fuat or Emre to do these, introductory. But don't be shy. This is the last point I can know about the foundational instruction you need. Email me with everything you need about Python. What you did with this exercise. If you couldn't do it, was it because of the time, or was it because you couldn't do something? Just email me, and then I'm going to arrange you another instructional session. But I need to make sure that I have the full list of people who need this tutorial session. Okay. Don't be shy, tell me what you need with Python, and I'm going to arrange a session for you. If you couldn't do this exercise for any reason, maybe time was too short, it's okay, but maybe you don't know how to import, you don't know how to use Jupyter, anything, you never done Python before, these are all okay. Just email me so that I know what to do with that. So the solution Uzay Hoca has is there. My suggestion, I'm going to now upload this recording on YouTube. It's probably going to be ready in 2 hours. Before the video, I would say revisit the code again, and do the exercise on your own time, at your home, calm, no time pressure. See if you continue to have problems or troubles, and let me know what training you need so that I can provide a session for you. Okay, I am stopping the recording.